Hello, this is Mr. Huff. Let's talk about one more formula. This is the range formula, and it's written like this on your formula chart. Normally, you will see this written like this in a physics textbook. It's the initial velocity squared times the sine of 2 times the angle divided by negative g. One of the things you need to recognize is that this formula will only work in one circumstance. You have to have a projectile being launched from the ground to the ground. These two have to be at exactly the same level, okay? And it is true projectile motion, so once it's launched, the velocity in the x direction doesn't change, and the y direction is accelerated by gravity. So this is a horizontal surface where we are launching from and to the ground. That's the only time this works. If this is up in the air, if you start with a cannon on top of a cliff and you're shooting at an angle and want to see how far it goes from there, this range formula will not work. You cannot use it in this situation. Only if it starts from the ground and ends up on the ground. Okay? So let's look at an example. We have a cannon here. It shoots a cannonball at 14 meters per second at an angle of 65 degrees. And gravitational acceleration is negative 9.81 meters per second squared. Sorry, I left the negative off there, but it's a negative number. So when we plug that into our formula, we have velocity squared times sine of 2 theta divided by minus g. Plug our numbers in. 14 squared times the sine of 2 times 65 degrees. Divide that by a positive 9.81 because negative gravity's already negative, so we have a negative of a negative, so now it's positive, and that will get us to an answer. So we plug this into the handy dandy calculator and make sure that you are in degrees when you do these calculations, or you will get really bizarre answers. So that means that that cannonball is going to go 15 meters about. So 15.3 meters is what I got on my calculator. So that's how far that would go. And that's all there is to say about the range formula. Remember, only in one case does it work.